In this video, we're going to be looking at spheres, and we're getting close to the end of looking at new basic 3D objects. You'll be pleased to hear. But we've left, I think, the best one to last. There's so many examples of spheres that surround us and make up us. They range from, at the largest range, sort of like stars and planets are spherical, um, all the way down through to the raindrops and cells of the body and little eggs, certain eggs, all the way down to the shape of fundamental particles that make up matter. So this spherical shape, which is very difficult to show this three-dimensional shape on a 2D page, but we all know what a sphere looks like. It's like a ball. So nature, for some reason, favours this sort of structure when it comes to natural things around us. But we won't get into that for the moment because there's plenty of other things to talk about, some basic things to talk about first. Like with all the other 3D objects, we're looking at volume and we're looking at surface area. So what is a volume? What is the area of the space, the value of this space which is contained within this ball? This, by the way, is the radius. So this is that's supposed to be an R, from the center of the sphere right the way to the edge. So the volume of a sphere is given by this formula, 4 over 3 pi r cubed, or to the power 3. And there's nothing much more to say about that. It's just one of these things that this is it. If you can try to learn that off that would be great. As far as the surface area is concerned, the formula for working out what the surface area of all of this surface is 4 pi r squared. And again, there's very little to say about that other than that happens to be the formula. And we can apply it to various situations. So here we have an example. So keep that sphere in mind because we're going to lose it as we scroll down. And this is an example of a question. And it's calculate the volume and surface area of a football, aka a sphere, with a radius of 12, so r equals 12 centimeters, and it's to one decimal place. So whatever the answer is, it'll be dot, and just one number after the dot. And that's the level of accuracy that they're asking for. So let's work out the volume. So this is really good. You put down the formula first, as I always say. So the volume of a sphere is 4 over 3 pi r cubed. And wherever you see sort of like nothing in between these letters, it means it's multiplication. So here it's expanded slightly. So 4 over 3 multiplied by pi multiplied by 12 cubed. Now what I would do is I'd have a number of different lines in there, just giving a little bit more detail. So I would say 4 over 3 times, and then I'd put in a value of pi, 3.1. Now it says to one decimal place, but when I did this calculation to one decimal place, I didn't get this answer. In fact, whatever I did, I didn't get this exact answer. Came close to it. But as long as you put in your working and every detail, then you should get quite a lot of marks for that. So this is 12 cubed, and 12 cubed needs a little bit of calculation. 12 cubed is 12 times 12 times 12. And when you do the calculation to saving time now, it comes to 1728. So we can put that in there, 1728. And when you do this multiplication, when I did it, I didn't get this number, but as I say, I came close to it. See what number you get, and you can sort of manipulate that. And what I did was I divided 3 into 4, and that gives you 1.33. That's an easy number to work with. times 3.14 times 1728. Now notice that the units are centimetres because the original measurement was in centimetres, and is cubed because it's a volume. Let's work out the surface area now of this sphere, and the formula is 4 pi r squared. So again they expand it, so 4 times pi times 12 squared. And again, I think I would, if I was you, I would put in another line, so b equals 4 times 3.14. So that tells the examiner the number that we're working with, times. Now this is 12 squared. You don't need to do any rough calculation because you should know from your 12 times table what this value is, but let's go through the motions. 12 times 12 is 144. So 144. And again, when I did this calculation, I didn't get this number. This is from, as you know, BBC Bite Size Maths. I'm sure they're correct, and I'm sure I'm making mistakes somewhere. But I didn't get this number, but I got close to it. And as I said before, as long as you share all you're working out, the examiner knows the numbers that you're working with. And if you haven't made a mistake multiplying all those together, then you should get quite a lot of marks. So what I would do is I play around with this and say change the radius to 13 centimetres or reduce it to 10 centimetres or whatever, and see what changing the radius by 1 centimetre, what effect that has on volume and surface area. And you should be quite surprised by the effect of just changing it a little bit. So good luck with all of that.